What's up, everyone? This is page 292. We're talking about another geometry fact, and it references the learning targets from page 279, so feel free to go back and look at that one to see that we're talking about proofs of vertical angle theorem. I'm going to recommend that you do have a highlighter, some different types of colors when you're drawing, or pencil, pen, etc., and that you also bring out the following vocabulary words. So find definition of congruent angles, make definition of supplementary angles. This is me making it for the first time with this activity. Subtraction property of equality, substitution property, given, reflexive property, linear pair postulate, and vertical angle theorem. I believe we're going to need all of those. Certainly, this is the topic related to things that we get to prove now for what you need to create. And then, because we are going to use these in this activity, it's like I'm saying, trying to bubble up the cards that we use all the time. Add a little tally to the number of times we've used that specific thing. We've used given like 3 times. We're going to use substitution in this lesson. We're going to use subtraction in this lesson. In this activity, we're going to use the definition of supplementary angles, which I created for the first time for this video, and then also the definition of congruent angles. Since we're using all of these, let's make sure that we're keeping track of how many times a card has been used. Let's get into it. Let's highlight habits of mind. Mathematicians must be able to reason abstractly and quantitatively, to construct viable arguments and critique the reasoning of others. Now that you've studied different forms of proof, we have flowchart proofs, we have 2-column proofs, you can use the properties and postulates you know to prove the conjecture you made about vertical angles in the previous topic. Remember, we conjectured, that's a statement about maybe how true something is, like a rule. We conjectured that vertical angles are congruent. That is what vertical angle theorem actually is. Vertical angles are congruent. But let's prove it, because it's not really a true statement just on its own. It needs some facts. It needs some logic. Use the diagram to write the prove statements for your conjecture. So we're missing the prove, and I'm going to stick with prove is pink and given is yellow. Maybe that's a way that I've worked through this all the way through, but I don't know. We'll highlight the things that we need to know. Bring in the color to your problem. Given angle 1 and angle 2 are a linear pair. So as a reminder, linear pair means that they form a line. So when you look at the diagram, those are things that we're looking for. We're looking for angle 1 and angle 2 to make a straight line. So add to the picture, angle 1 and angle 2 actually make that straight line kind of on the slant. Got a different color pencil for the other one. Angle 2 and angle 3 are a linear pair. So angle 2 and angle 3 right here. This angle and this angle together, those ones form a linear pair. All right. So if angle 1 and then 2 and then 2, and these are the 3 angles that are mentioned, there's a common angle 2 between them. So our prove statement, angle 1 is congruent to angle 3. Now I chose angle 1 and angle 3 because it's kind of like there's this line of thinking that goes from left side to right side, and in there, angle 1 to angle 3, it says angle 1, and then it's connected to angle 2, and then it's connected to angle 3. So that 2 in the middle we're going to pull out and say that 1 and 3 must be the same. That is a substitution that we're going to need to do. So we're going to absolutely have to think about how 2 is going to swap out. Let's go to the other one. Angle 2 and angle 3 form a linear pair. So there they are, linear pair, angle 2. And then it mentions angle 3 and angle 4 form a linear pair. And so if angle 3 and angle 4 form a linear pair also, and it's angle 3 that's common between the 2 and the 4 angles, then the thing that we must prove is that angle 2 and angle 4 are vertical angles, but they are congruent. We're always trying to prove congruence, the fact that things are the same size. Well, The worked example is a flowchart proof for our statements. So if we take the given from what we wrote down, and then as we take the given and continue to fill out the pieces, angle 1 and 2 are a linear pair. This angle 1 and angle 2, that's given. This angle 2 and angle 3, that's given. Uses given. So I'm going to make sure that I'm reminding you, that we need to always be looking for the givens in the problems that we're doing. Linear pair postulate. Okay, so if things form a linear pair, do you see how linear pair was used in the given? It actually becomes the reason in the next step down. So if you notice a vocabulary word, which is why it's so important to have these note cards, if you notice a vocabulary word up here in the given statement, you take that vocabulary word and it will become the next block. The arrow down from that block, it'll become the next reason. Linear pair points to something we call the linear pair postulate. And as a reminder, it's not there. Where did linear pair postulate go? Here it is. So I know that if this was a vocabulary word, I'm going to have to find that note card, and I'm going to have to use that note card. Okay, if they're linear pair, then they are supplementary. And that's why the definition also points us to the word supplementary, and I underlined it and I wrote what that means. So I'm going to put that here. Linear pair creates supplementary angles. But do you see that right there? That's a vocabulary word in this statement. So if I have a vocabulary word in the statement, then that's going to become the next box's reason. Definition of supplementary. So I needed that definition of supplementary. It means that two angles add to 180 degrees. There we go. The vocabulary word of this box is going to become the reason of the next box down. And we have to write a statement that uses that reason. The two angles add up to 180 degrees. Now we use substitution. We have a 180 in both of these boxes. So if you see matching numbers in both of those boxes, then that tells us with substitution that we can bring those boxes together. And so that's what's happening here is both of these expressions equal 180. So therefore, if they both equal 180, they equal each other. Substitution, bring them together. Now we need this reflexive property. So I lost it. It fell on the floor. We need the reflexive property because it turns out angle 2 is mentioned in both of them. I mean, that's what I identified up here when I circled. It's that angle 2 is written in two different given statements. So seeing that, I knew I needed to bring in reflexive here. I have angle 2 used in the first angle pair, and angle 2, it's the same one used in the next angle pair. They come together, and then in bringing them together, I'm just going to swap them out. So we use subtraction property. That also fell on the floor. We use a subtraction property to cancel the angle 2. We take it away from both of them equally. 2 is gone, 2 is gone. What's left is angle 1 equals angle 3. And then when you have that angles are the same size, they must therefore be congruent. Thank you for watching this video. We're going to go on to page 293 next and analyze what's going on with the different steps. Thank you for following along, for building your note cards, and for learning a little bit more about proofs. See you on page 293.